We're going to continue our study of exponents, and this time we're going to talk about how to solve exponential equations. All right, so we've graphed them, we went over exponent rules, but now what happens when we need to find a variable, in an exponential equation? So we're going to look at a couple examples here. So this is 3 to the power of x plus 1, and we have 3 to the power of 5. So in this example, this is important because this becomes the foundation for everything we're doing. They have the same base. So in this case, the base is both 3. So one of the properties we can use is if they have the same base, we can just get rid of the base and then solve for what remains. And so again, we get rid of the bases because they are identical, and we have x plus 1 is equal to 5, and that becomes just a one-step equation. All right, so let's take a look at these next ones. So again, what you're looking for is the same base. So in this problem, the bases are the same. Now this 6 is to the power of 1. So we can get rid of 6, we can get rid of 6, and so now we're left with 1 equals 2x minus 3. All right, and then for this, you just would finish off the equation and solve for x. There you go, so solve for x that way. So again, what is the most important thing we need to do? We need the base to be the same. All right, over here, are the bases the same? They are. Okay, so we can cancel those out. I get 3x is equal to 2x plus 3, and then I would end up getting x is equal to 3 as my solution. So that becomes the foundational rule for all of exponential equations. When we want to try to find what the variable is equal to, we have to have bases that are the same. Now, obviously this is a very simple example that you see, and as with most things in math, they do get a little bit more complicated, but not really. We just keep the same rule, but we apply it differently. So now here is an example, a couple of them where the bases are not the same, but we still need the rule that we just used. We have to get the bases to be the same. So in this case, we have this problem, 5 to the x equals 125. Well, we have a base of 5 and a base of 125. They're not the same, but we need them the same. So here is the tip for you guys. We want to take the smaller base and make it in both sides of the equation. So how do we make 125 with a base of 3? Well, that would become 5 to the third power. So depending on the number that's given to you guys, you might need to use the calculator to figure out what the exponent needs to be to make that base the same. All right, so again, we take the smaller base, and so the smaller base is 5, now we have 5 and 5. This stays the same, and now we have to take 125 and make it with a base of 5. And in this case, we have x equaling to 3. All right, so now let's look here. We have 4 to the x and 2 to the x minus 3. So what do? We take the smaller base. So in this case, the smaller base is 2. We have x minus 3. And now we need to make that a power of 2. So how do we make 2 4? Well, 2 times 2 is 4. So this would be 2 squared x, or 2 to the 2x power. So now we have same basis, and now we can solve our equation, and we would get x equaling to negative 3. Okay? All right, let's take a look at the next one. Again, we take the smaller base. So the smaller base is 9. So this stays the same. This number we need to write as a base of 9. So what is 9 to the 27th power? Right, 9 to the 27th power. Well, that one's a little bit tricky because we can't do it, right? So what if we rewrote it with another base that makes it the same? So in this case, what if we used 3? So if I had 3, what would we do to get 9? Well, that would be 2. So it'd be 3 times 2 times x plus 2, because 3 squared is 9. Over here, what would 3 be? Well, 3 times 3 times 3 is 27. And then we would have our equation. So sometimes it's pretty easy, and sometimes we need to use kind of a factor tree model to figure out what it is. And so the factor tree, just to review, if I had 27, that factors into 9 times 3, and then this factors into 3 times 3. So if we want all the bases the same, we have 1, 2, 3 3's, which gives us 3 to the third power. Okay, so that one's a little bit tricky, but it can still be done. All right, now, what if we have a base that is a fraction less than 1, but greater than 0? So what we're going to do in this case, these are fractions here, 1/2. We're going to rewrite the fraction as a negative exponent. So if you remember the rules with negative exponents, if we want to move something up and down, we can make it negative or positive. And so that's what we're doing here in this case, is we take 1/2, and 2 is going to be our base because this is 4, and we want the bases the same, and we're going to use the smaller base to help us get there. So in this case, we want to write this as a base of 2, which is 2 squared. But now we need this to be a base of 2, and not a base of 1/2. So what we're going to do in this case is we have to move the 2 up. So the 2 is positive, and when we move it, it becomes negative. Right? So that's where the negative 1 power comes into play. So now we have our base. We pull that negative sign outside, and now we have our expression here, our equation that we can solve. Okay, let's take a look at this last one. So in this last example, we have 4 and then x plus 1 and then 1 over 64. So in this case, again, we want to convert 64 into a base of 4. So we end up finding out 64, if we want to factor tree this, right? Well, we know it's 8 times 8, and that's 2 times 4, and 2 times 4. Okay, so we see there's 1, 2 4's, and then this would make another factor of 4, and so we get 4 to the third power. And if this, as I go through it quickly, if this doesn't make sense, look up factor trees, and we can, and you can kind of review some of those concepts that were probably introduced to you a couple of years ago in math class. All right, so now we have the same base. So we have 1 over 4 to the third power, but we need it up top. So when we move it up top, it now becomes a negative 3. So we have our x plus 1 and our negative 3 right there. Okay. Now, as we've seen in just about all the different types of equations, we do have to graph them as well. Graphing is a big part of algebra. So when we look at this, we're going to be given 2 equations. We have 1/2, the power of x minus 1 equals 7, and then we'll do a second example in a second. So when we look at this example, what we want to do is graph these 2 equations. So in your graphing calculator, we're going to graph these 2. So we're going to graph 1/2 x minus 1, and that's going to give us this red line, and then we're going to graph y equals 7. And where they intersect is the solution. So this ties in the different graphing lessons we've had in the past where intersections are solutions. Okay? So in this case, we're going to only have one solution, which is this coordinate right here. Now the graphing calculator software that you use, or the actual graphing calculator, will have some method to tell you what the value is at that intersection. In this case, the value is going to need to be rounded for the x, and so it will be 1.8 or 1.81, depending on what the problem asks you to do for rounding. Okay. So let's take a look at the next one. Again, what do we do in these steps? We're going to graph these 2 equations on the graphing calculator. So we take 3 to x plus 2, and that's going to be the red exponent. And remember, that's a horizontal shift to the left 2 units. So it would be here, and then it would be 2 units over would be the horizontal shift to that graph. All right, x plus 1 is this one here. Now, what do we notice about these graphs? Do they intersect? They do not. So because they do not intersect, right, there's no intersection, there's no solution, okay? So that would be one of those situations that might confuse you because it doesn't intersect, but it goes back to the rules we had. If the graphs don't intersect, it's no solution. There is a lot of new stuff here, so again, if you need to stop this and review it and work through it and think it through, go ahead and stop the video at the points that you need to review. Figure it out yourself, see if you can do it. But just like so many things, there's a few rules, and you just need a lot of practice.